All right. Okay. Hey, real quick. Homework, page 87, have it out. So if you actually put it in the back basket, we'll grab it. I think there's one back there. Must be something else. All right. So what I want to do real quick is just make sure that you're doing the thing that I asked you to do, and you didn't do what the crazy book instructions said. The book instructions wanted you to find slope, like between the outsides, between the insides, and then you can approximate what the slope is at the center. So you go the outside, the inside, and you kind of find a few numbers. You did not have to do that. What I want you to do to estimate what f prime of 2 is, that's the first derivative, is to actually do the derivative definition, which is this one. Oops, excuse me.
Whoa!
Stop. All right. You approximate h to 0. You do this part where you add in h, you subtract the original thing, and then you divide by h. And once you simplify this, so we have x cubed. So I'm going to go x plus h cubed
Hey, I have that
minus x cubed over h. You did all your math. Eventually, you'd have to plug in. You divide by h. You'd eventually plug in all the h's or zeros, and you'd eventually get to 3x squared. And you'd have to plug in 2 into that, because I want to know what this thing, because this is at prime of x, by the way. You'd have to plug in a 2, and what you get eventually is you get 3 times 2 squared, so that's 4 times 3, which is 12. That should be, that's evaluating what that number is. That's the slope at 2 on that graph.
It smells like food in here.
Okay. So, all right. Any questions with the concept? What you're doing? You're going to do that the same for the next problems. Oh, this red. Why do I even use it?
Oh, my
Guys,
God.
don't let blind people be so
Just stop.
Throw away work if they were actually.
No, it's just that one red marker. I switch markers right before you walk in, and it never erases. It's just earlier it was a blue marker.
You could be like,
Now it's a brand new marker. So
Well, yeah, but it's gonna run your board, it's not worth it.
I have a
and eventually
question.
it'll wear out.
Does the school fund your towels?
No.
Wait, you really missed a slide. Oh my God.
Those towels, did you take them from the locker?
That's somebody calling me on a particular phone. This is a student calling me. I'm taking the phone. All right. So, okay, question number 1. Does everyone feel comfortable with finding slope?
yes.
Okay. All right. Number 2. Question number 2. Exactly the same style of problem. You have to find the instantaneous rate of change. So that's the derivative. That's what an instantaneous rate of change is at x cubed. It's the same problem. But now you're plugging in 1. It was the same problem. It was just you had to go find, and you had to understand the difference between instantaneous versus if they said f prime. It's the same thing. Okay? Question number 3. They gave you this big, long explanation. Now, if you look back in the book, and a couple sections before, they explain how to do this with a big table where you plug in numbers that are really close to, which are these two numbers. You plug in these two numbers, 2 and 1, into the function. That way you figure out the f values for this thing. And so you could subtract the y numbers on the top, whenever those y numbers come out. You subtract the 2 x numbers, which are 2 and 1. That way you figure out what the average slope is. You find the average slope for back here, so there's another one you'd have to do. And eventually, bless you, you'd figure out the slope in the middle of them. Well, that's too long. All you have to do was take this thing and do that first derivative test to it. So you're going to take this function and figure out what f prime is. Well, f prime should be 100 minus 20 cubed, and you plug in what number they want me to plug in, 2 into that thing. So eventually it would turn out to be 60. That's with the 2 plugged into it. Okay? That's the concept of what they want you to do there. Find the value of their instantaneous rate of change at, q being 2. Okay? Questions, comments about how you want to do it?
No.
All right, moving on. Because I wanted you to just give this concept. So as you're seeing, like every problem I'm doing all the same way, every single time. Next ones, you graph the function. Okay, now this one is comparing which one is bigger. So this one is the one that I was kind of hoping that you guys would take a little more time on to just wrap your head around like what the values mean. So this is the whole point of what I've been talking about is, where's my, okay, all right, let me zoom in here. Okay, so what I'm talking about here is I want you to know the difference between a function value and a derivative value. Okay, function value is whatever number is on the curve. Okay, that's what these are. The f primes, these are what the slope is at that moment. So like to do to do letter C here, to do that letter, all you had to do was kind of estimate what the slope is. So at 1, the slope is, let's say it's rise 2, run 1. At 4, the slope is really steep, it's nearly 0. So the bigger number is that one. By just looking at the picture and understanding what slope means. I didn't even need to go find a number for it. You just have to understand the simple concept of what that number is. That slope is how it's tilting, and what slope is, it's rise over run, so that top number is bigger than the run number is, if it's going really steep. Okay, so I could guesstimate those numbers without having to evaluate them, okay? All right, now, doing that first question here, this is f of 2, f of 5, f of 2 answers right here, f of 5 answers up here, it's just slightly higher, so that's the bigger number. Okay, any questions with that one? All right, let's go to the next one. Okay. Okay, so this figure for the graph is shown, it's got all these derivatives given to you. All you had to figure out is where that derivative should be. This one that I kind of gave you, I think it was like last Thursday or Friday, kind of give it kind of an estimate of what this thing, or earlier this week, I shouldn't say Thursday or Friday, it was like Monday or Tuesday this week. How did it approach this problem? If you're right here at letter A, what type of slope is that?
Yeah,
Oh, negative slope. It could be a small number. Yeah, I'm expecting it to be, it's not really super steep, so maybe negative 2 maybe, or negative 0.5. I would accept either one of those. What do you think? I would say negative 0.5 probably if I'm comparing all 5 of these. Just because at B, it's going back up, so I'd say that's positive 0.5. Letter C is a little more steep, maybe that's 2. Letter D is 0 slope. And this letter E is really steep. I would say that's probably negative 2. Like, just kind of like guesstimating, and that the reason why I picked this problem is because if you understand the concept of what slope is, like it's just the slope at the tangent line right there, you could have went back a number, what is that, problem number 10, and figure out what they were asking for, or go back and go, okay, my slope here at 1 was smaller than the slope at, or was bigger than the slope at 4, because of the way that the line is tilting, that type of thing. So that's why I was kind of particular on the problems I picked. All right, moving on, let's go to number 12.
Between your two eyes is the same.
Okay, so this one, it has all the points A, B, C, D on the graph. We have to label these. So I was hoping on this problem, you have this picture roughly drawn, and then you're putting these spots on that graph. So point A would be in a certain location, B would be in a certain location, D and C. And you kind of picked a spot and it had to make somewhat sense, okay? All right, if they wanted the derivative to be 0, it would have to be like here, or there. That's where the slope would be 0, where it does a turning point. That would be like letter D. I would expect 3 different spots. It could be one of the 3. So I just want you to get kind of a feel for how to do that. Any questions on the concept of what I wanted on number 12? Okay, 13. Jeez. I didn't realize how zoomed in I was.
That's a lot of zoomage.
That is a lot of zoom.
But you went like 120%.
Okay, there we go. All right. So the function value for this graph, you had, and this one I was trying to explain. I think on Tuesday this week, I was trying to explain the concept of this one. Okay. You have f of 4 being 25. So this coordinate right here is 4, comma 25. Now how I know that is that this is a function value. It's not a derivative. So it's the actual spot on the graph, right? And what they want you to find are the locations, the coordinates for this, this, and this. Well, I already told you the first one. They actually told me you just had to realize what that thing is. It's 4, comma 25. The slope at 4, at this spot, the slope right here is 1.5. So the actual slope is 1.5, which is 3 over 2, if you don't know. If I just want to write that as a fraction. Okay, now why that's important. I can figure out where those locations are for B and C by just doing common sense math with a line. Because the slope right here, the first derivative, that's just the line, that's the tangent line that they have labeled. So if I just write the equation for the tangent line, where I'm going to use y minus the y number, so y minus 25, my slope is 3/2, x minus the x number, that's the generic formula for the line for the tangent. Because I know it went through letter A, I already know the coordinate for A, that was 4/25, the slope was 3/2 at that exact moment, and the slope is probably going to stay the same for the rest of that tangent line. So if I want to figure out where the coordinates are for, let's say, 3.9, just plug 3.9 in here. And now you can figure out what the number is for y, like the actual coordinate for 3.9, by just solving for the y. Because I would, this would be negative 0.1, you take negative 0.1 times this, which is negative 1.5, or negative 0.15, and then you'd add the 25 across.
Number 17. 13?
Yeah.
No.
17.
That is 17.
You would add the 25 across, and you add to the negative 0.15, and that would be a positive 24.85.
Why'd you write question 13 but this is 17?
I don't know. That's weird. I don't
That
know.
is
It
weird.
probably should have been 17. Sorry.
Yeah, 'cause we have 13 too.
Okay.
That's okay.
Yeah, I think we just did 13. All right.
Yep.
Questions on how to approach that problem? Now so I already figured out 3.9. It better be 24.85 or something like that.
Yep.
Okay, so I was doing that without a calculator. So I'm just trying to show you like the simple ways to it. That the first derivative is slope, so you can just write a line and you can approach. We could have done this style of problem for your ball drop activity to figure out what would happen at 50, because we have the slope at any particular point by just guesstimating where the slope is, and then we could use that predictor to actually figure out what would happen at 50. And that was the whole point of doing that activity. All right, next. I think I just picked another one that was exactly the same style of problem. Okay, 18.
This was
Oh,
18.
18, all right. I don't know why, I just had 13 on the last one. Ooh, skipping ahead. Okay, all right, so figure 2.3, here it is. You're gonna figure out where g of this is equal to this. So you could have picked any of these points, but I would say that if you wanna figure out point B, what was the number you plugged into point B?
2.
2.
And you got 5.
And you got 5 out of it. I want you to understand what that symbol means. It means you're evaluating the function at the x number and it equals the y number. The slope. Well, you just have to find the slope between these two. The slope at 2 would be whatever the slope is there for figuring out those numbers. 5.02 minus the 5. The 1.95 divided by 2.
Minus 2.
Minus 2, sorry.
It's
what is it?
negative 0.4.
Okay, negative 0.4. 0.4, right?
Yep.
So that's your slope, that'd be the number right here. Because the first derivative is the slope at that location, so you gotta go find slope. Questions at all about how I did it?
No.
All right, moving on. Yeah, I was trying to pick very specific problems that weren't like super difficult, but it gave you this idea, it was like a building idea of what the first derivative is.
Let's do 25. Or
Okay,
25.
22 and 25 and 23 are all basically the same style of problem. They're giving you like either a function and a number to plug in. You're finding instantaneous velocity. This is where you're sketching a function. This is a quadratic. You can figure out where it's crossing. So this one I just wanted a rough sketch. The tangent line at 3, what it's going to do, that type of thing. Any particular problem you want me to show you?
Nope.
Okay. They're all basically the same. They're just kind of asking for what that picture looks like or what kind of picture it is. Just remember about an even and odd function.
Show us even and odd.
On even functions are balanced over the the y-axis. So the slopes at these locations are exact opposite numbers. So if the slope here is 4, the slope over here is -4 on an even function. On an odd function, they would look like this. The pictures are like over the origin, so the slopes are exactly the same number over an odd function. So if like this slope here is 2/1, the slope over here is still 2/1, even though you're on the other side of the x-axis.
What
They're
number
perfectly
was that?
balanced.
Can you do 22?
That'd be like 20, that'd be 23.
Can you do 22B?
22b.
Yeah.
If f is an even function, kind of like this, where f of 0 actually exists, what is f of 0? Well, if it's even, so that means it's balanced over this axis.
So
So-
looking for the F prime.
So f prime, so this actual value exists, that's your picture.
It's 0.
It's 0,
Okay,
slope
that's
is
what I
0.
put, but I just
So, because if it's actually even, it's going through the, like the origin, so, or maybe it's above or below the origin, but it's a bowl shape, right there,
It's a
perfectly.
bold shape.
Okay, it could be the other way around, it could be this, but whatever's happening, it's the same on this side and this side, so there had to be like a hill or a
Are
valley.
you gonna do number 25? Why? She has to. I don't know if I did it right or not.
Okay, next one, this problem, to find the function, the values of it are this. If I factor in x, that means I'm passing through 0 and -1, so this is what it's gonna look like. And what would the value be at x of 3? You could plug in 3 and see where that thing's gonna be. It'd be 3 times 4, so it'd be at 12 up here, so 3 times 12. And what would the tangent line be right there? You just do the normal derivative formula to that thing, and then plug in 3 and figure out what the tangent is.
7.
A tangent line is the slope right there.
Wait, but I didn't get 7, I had 6.
Well, didn't you get 7 plus h?
It should be 6x plus 1. So then you should be able to plug in the 3, so I can get like a certain slope there. I would expect that the slope
Why'd you minus 9?
would
It'd
be
be like
7
86.
right
You
there.
have to plug in the one thing, the fx.
F of X plus H.
Because that's what a tangent line is. You're running the slope right there.
And you had to plug in 3 to that thing, so 3 squared is 9, plus 3. So that's the f of x, and then you subtract that from the whole
5,
thing.
6, 7, 8.
Straightforward.
Good shot.
All right. Here's all you do. If you have your answers, you feel comfortable, go turn them in either the front or back right now, and then go back and take a seat. Hopefully, we're going to try to do that from now
I'm
on,
very confused.
where we have a really big assignment.
Yeah,
So you find slope.
but I think I did that wrong because I.
Did you hear Dalton when your phone was ringing? He said, "Mr. Phone, your ward is calling."
Mr. Ward, what's your favorite food to eat out of the bowl?
No, it's not.
You have to do it. You want to do X plus H and all that stuff? Usually you put like 1.5
Did that.
Yeah, and then you can plug 3
Then
in.
you have to simplify it to eventually.
Why did you add X plus H again?
Because there's 2 x's. So you have to put the x plus h into both. Is that what you forgot?
But then you have to plug 3 into the f.
Eventually, it's going to turn out to be 2x plus 1. Once all the h's are 0.
Oh,
And then you can plug 3, so it's going to be eventually, the slope there will be eventually.
I just started out with a 3 within the x already.
And then that'll help you figure out that function, that tangent line. That, you can draw that tangent line over, yeah. Up 7 over 1, up 7 over 1, that's the tangent.
I just forgot one of my, the second.
Hey, Dalton's still
Alright. What we're gonna do today, as kind of our notes today, we're gonna do an activity where we do it all together, because I kind of like the way we did this today, where we talked about problems, but we're gonna do it on here, and I want to show you, we're gonna introduce some new stuff. So we hand these out, we're gonna do this together today, this is kind of our goal. Now, it's not 74 different problems, there's 4 problems on the top, and the answers are multiple choice below it. So it's not like 74 different graphs, it's one graph at the top, and then A, B, C, or D below it.
This
But it doesn't even look like 74.
I think there's 2 there in that one. There is 2.
This is actually only 20 graphs, so that's not close to 74.
Oh, you're really good.
He tried though, didn't he?
So what you're saying is this isn't 74 different graphs? No. Whoa, that's a big one.
Okay.
Yeah, we formed one by four. That's usually
Okay, hey, does everyone have one? Everyone's got one?
Yeah.
Yeah,
Okay,
so
I'm gonna pull this up. Alright, here we go.
Good.
Did you get this?
Not the right answer, but kind of confused.
Are you okay, Jake?
No.
Did you say God?
I do, but it's like, I don't know, I don't.
Just having dogs in trouble.
Alright, here we go.
God, she said it.
Okay.
Alright, let's go through problem number 1 here. Okay, this is a multiple choice question. It's trying to get you to get a sense for how to look at slope and graph what slope is. So here's what I'm talking about. There's this chart you can do in calculus where it helps you graph slope. There's slope graphs. You can actually see if the problem is increasing or decreasing. Because some companies actually like to see not just what their sales numbers are, but their potential growth numbers. And that's what slope is. It's a rate of change for growth. It's either positive or negative. So there's this one chart you can do. So this is my function, right? So the function is going down, up, down. So you are eventually losing money, you gain money for a while, and you lose money, okay? Now, when it started to gain money, that happened about right here. There's this weird little inflection point. And then it had another inflection point right here where it started to change course and it went back to negative again. So then the idea is that there's this chart that you do where you just make a number line. Okay, so I'd like you to make a number line like this. This is going to help us find my final
On the
answer.
back of this?
Just put it just right above it. Right above it.
Ours is tiny.
So make your little chart above it.
Ew.
Okay. All right, and you can put your name on this, by the way. All right, if you haven't already. All right, so now that we have this, what we're going to do, and again, you can put it above, or you can put it anywhere you like. All right, what I want you to do is kind of estimate where did it hit that inflection point for the x number?
-1.
Negative.
No, it's like
No.
1.5. 1.33.
Oh,
Yeah, okay.
I thought it
So
was, yeah.
negative 1.33.
I'm so glad he took my number.
Okay, so that's roughly about where that thing turned directions. This is because it's going by 2, so we're past the number 1 just a little bit on the x numbers. That's where it suddenly changed directions. Now, it changed directions again at 0, and then it kind of went off. But here's what I want to talk about. Is okay, so you got those numbers marked on your number line. Those are really the only numbers we need. Okay, just where it changes directions. Okay, what I want you to put is what is this type of slope? It's positive, negative, or 0, or undefined. What type of slope do you have on this side of your graph?
-1.
Negative slope, right? So here's what I like you to do. I like you to put a bunch of negative signs over here. Just a bunch of negatives. Okay?
Then it's
This-
0. And it's
Okay, so then on negative 1.3, we had a slope of 0, because it suddenly changed directions.
So we just write a bunch of zeros?
No,
No.
just 1, 0. So it only changed one direction. And then it went to what type of slope right after that?
Positive.
Yeah, it went to positive slope for a little while. So you're gonna put a couple positives in here.
It's like 4.
And then eventually we hit 0 slope again, because it changed direction. It had a hilltop again, because hilltops have a slope of 0. And then it went suddenly to what type of slope over here?
Negative.
Negative. So we have a bunch of negatives. All right, so what you're looking at here is a rough guesstimate of the idea of what slope is. So for a few odd months, this company had positive slope. It had growth for a while. Then it went back into negatives again. Maybe there was some marketing strategy that worked. They might want to stick with that. They can look back at the numbers they had over like a couple fiscal years. Okay, it's nice to do that. A lot of tech companies don't have to release numbers. They do. And then a lot of tech journalists keep track of all those numbers for years to see, like, was there positive growth, negative, and they compare. Most companies don't look back that far because they just kind of forget about it. Okay, now, here's what we have to figure out. You have to figure out which graph below, A, B, C, or D, represents this type of numbers. So what I mean by that is you look down below, I'm going to scroll down, and what this graph is you have to give me graphs where the numbers, so if you look at my chart over there, the numbers to the left of negative 1.3 will be negatives, past 1.3 is positive numbers, and then past 0, they're all negative numbers. So which graph is it?
C.
C. All right, so let's look at this one. I agree. Letter C, this graph right here, is a physical representation of these slope numbers. They're actually, what you're seeing here is they're plotting the difference in slopes over that graph. So as you can see this, my slope was negative. These are all my slope numbers. They're all negative. They're getting closer and closer to 0. Eventually I hit 0 slope, and they went positive for a while, but changed directions, went back to 0, and then went all negative slopes again. So what you're seeing here, this graph for letter C, is literally the graphical representation of slope. Slope was actually changing. If I go back to that original graph, and you kind of guess what types of slope numbers you have. So let me scroll here. If we go back up to this graph, you can actually see that the slope was really steep negative, so really big negative numbers. And then eventually it started to taper off, or the slope was getting smaller and smaller until you hit 0. Then it got positive and growed, and then it got back to 0 again. And, then it was really negative, and it started to go off from there. Okay, so you got to figure it out. All right, for the next one, I like to put a number line above the second graph now.
Can you do me a favor?
No. Okay. All right. Number 2. Okay, number 2. We're going to do the same thing. I want to know, where's my inflection point where it changed directions?
Negative.
No, X numbers. Give me the X numbers. Where did it suddenly change directions?
Yeah.
Negative
Yeah,
0.
great.
Negative 6.
Negative 5.
Negative
No,
6.
negative 6.
Well-
0.
What?
It changed directions on number 2 at 0
Oh, you started going
for
up.
the X numbers, because all these slopes over here were all negatives, and suddenly it switched directions. And again, you're giving me the X numbers, not the Y numbers. So at 0, I suddenly changed directions, and then the slopes went different. What types of slopes I have over here?
Positive.
Positive.
So we just
Okay.
put 0.
So the idea is that I have a bunch of negative slopes. It eventually hit 0, and then I had a bunch of positive slopes. Okay, so now you have to go down below A, B, C, or D. Which one is a physical representation of negative numbers, 0 positive numbers?
A.
Right? A, and I'd probably agree with that. Okay.
Probably.
Just because these numbers are above, so these weren't negative numbers. These are positives, no. These were negatives, it eventually hit 0 and positive. But it was starting to taper off. Like these are saying that my slopes are getting bigger and bigger and bigger. If you actually look at my graph way up here, the slopes actually taper. They almost turn out to be 0 eventually over here. So I'd say that this is a great representation of your graph.
So does C not work even though
So-
it's still all positive active?
It went from negative to 0 to positive. It's just that what this graph represents is that your slope is getting bigger and bigger and bigger.
Why
I don't have
does
that
that?
situation. What?
Why is that?
Yeah, so the idea is that, yeah, this wouldn't happen. So it's not gonna be that graph, because our slope was eventually, on the original graph, the slope was approaching 0 for a while. So it would have to go up for a while and come back down. So that was kind of the idea. Letter D, the numbers are backwards, because they had positive slopes and then they went to negative slopes. Yeah, I can't have that. So, all right, do we get the idea here?
Yes.
Okay, I'm not gonna go to 3 or 4.
They're confusing though.
Okay, 3 and 4, you can do the same thing. We set up the charts. They just happen to be a break in the graph. You'd actually have a physical break. So
You get points for this?
if they have, yeah, we're gonna get points for this participation. If they have breaks in the graph, your slope down here will have physical breaks in the graph. So like, how many breaks are on this picture?
0.
1. There's 1 break in here. So on your slope formulas, there better be a break in the graph, and you just have to figure this
So you
out.
can
Like,
eliminate D.
if I was looking at this problem, it looks like the slope is nearly 0. It's positive though, but it's nearly 0, it kind of spikes, and then the slope gets bigger, bigger, bigger. And then there's a break in the graph, the slope is positive, and it gets almost to 0. I would say a really good representation is probably this one.
What about B?
Okay?
Look at B.
Because the
Same
slope
graph.
is 0, it's climbing until it gets really, really big numbers for slope. There's a break, and then the slope is positive, really tall numbers, and eventually it tapers off to 0. Now, we're saying there's a lot of B's in here.
Yeah, it's the exact
Okay.
same graph.
B. So let's take a look at B. B has this moment on this one. Is this it?
No, the other
No,
one.
over here, right there. They're saying that the slope is positive, right? And then they're saying that the slope is negative numbers. So is my slope negative on this side of the graph?
No.
No, my slopes are on this side of the positive numbers.
We're talking about slope?
Yeah, these graphs I'm giving you down here are all representation of the
I
slope
don't know, I don't
numbers.
understand.
So like, what
Yeah,
B,
what's this thing that makes no sense?
so what B is, the slope is 0, it kind of climbs, but then they're saying the slope is negative numbers, negative slopes approaching 0. My slope wasn't negative up there at any point in my graph. We said, is it C? So, what do you think we're saying? Okay, let's look at C. What they're saying on this graph is that all the slopes were negative numbers. Like these are the actual numbers for slope. So at -8, they're saying on this graph, this one, that your slope was a negative number. It wasn't. It was a positive number, but it was nearly 0. So they have these numbers on the wrong side of the graph. Because
So if those numbers would have been
these,
flipped up,
what these numbers actually are on this graph, it's the actual slope. So if you were to go really find the slope number, the real slope, it would be a dot on this graph somewhere.
Yeah, I don't
So-
understand why B doesn't work.
I don't understand B.
Okay, so let's
really
take,
don't.
let's take a look at B.
I understand what
B
A
is saying that on this side of the graph, all of your slopes were zeros and then they climbed up to be positive, right? That's kind of happening way up
Yeah.
there. But on this side of the graph, they're saying all your slopes were negatives. Negative numbers.
Yeah, but so is
Your
this
slopes are
graph.
never negative. Because if you look at the graph, the original graph up there,
It's the same thing.
slope,
no, no.
it's increasing, I get it now, that
So-
took a really long time.
Okay, on this side, slope was always positive, right? Slopes are positive, they're going up to the right.
Yeah.
On this one, the slopes are all positives. So there's no negative numbers for slope. They're always climbing up to the right.
How is it not?
If the graph was the other way, wait, if the graph was the other way around where it was
I
like
don't
flat
get
and
it.
then went down,
So
then
good because the bottom one does the
Yeah.
same thing.
Yes, it
What-
does
what are
the
you
same
talking
thing, it's just shifted up a little bit.
Yes, the number B, it literally does, it goes
No,
in that
no,
Okay,
way.
wait, no, no,
no.
sit. Sit. Give me a slope that's positive. Give me any number
One.
that's positive. 1. Okay? If you go look at the B graph over here, you're saying that this slope right here is 1. You go look at the B graph down here. On this side at 1 is your slope, the number 1 right there.
It's not that on there either.
No, this graph is. This is the original picture. These are the slopes graphs.
I'm sad, cause I understand, but I get how frustrated
Alright, I'm
you are,
moving
cause I didn't get it.
No,
I'm moving on,
this is
because
not okay.
right now, all it's gonna be is battle, because we're not getting it, so I'm just gonna move on from that one. Okay, we'll come back to it later,
Probably should have 4.
because all it's gonna turn into a battle, and I don't need that. So, okay, we're moving on to the next one. You have to find the derivative. Okay, so we have to find the derivative of these. Okay, so if this was the type of problem on your next test, okay, where you had to find derivatives, this is the ones where you have to do this formula. Limit as h approaches 0, f of x plus h, subtracting f of x, and you're dividing everything by h.
Well, I just want you to know that I get it now.
Okay.
I just want you to know I don't.
Okay. So, alright. So you have to do these formulas for these types of problems. You'd actually simplify, you'd actually plug in h of 0 into these. Eventually you'll figure out that the first derivative at whatever number you want to get will be this thing simplified, and eventually you'll figure out the slope should be -2 if you plug in h of 0 into that first problem. Notice we don't have any x numbers to plug in to evaluate. They just want you to find slope if h was 0. So you're just going to go, you're going to simplify this thing down where it's going to be, you know, in this problem, this is going to be -2x plus h plus 5. And then it's going to be subtracting the -2x plus 5, and that'll be a plus, basically. And then you have the h on the bottom, and eventually it'll simplify to be like -2x h, and eventually the
No.
x's will cancel. It'll be a
No,
-2x
it's simply-
minus 2h plus 5 plus 2x minus 5, so the 5's and the 2x's will cancel. So it'll be left with like a
How do
2h.
fives cancel?
It's, yeah, -2h.
Yeah,
And
negative
then-
2h, and then when the h's all approach 0, this is basically your slope.
Wait, how do you get that? If you plug 0 into h, then it's just gonna be 0. Cause I was,
Negative 2x,
Like, can you do
You
all
don't have to
four?
plug 0 into h, just,
yeah.
negative 2h,
no,
Plus
because you take the h
5.
away first.
you'd have plus 2x minus 5. The 5's cancel, the 2x cancels, and you're gonna have
Oh,
negative
okay.
2h over h, those cancel.
Oh, the-
Right.
oh, I forgot about the.
Yeah, you got the h on the bottom still, you gotta cancel it out, so your slope is negative 2 good. Okay, so these are problems you gotta get comfortable with. Can you find slope in these situations? We'll get back to the graphs at the top here in a minute. But then, can we actually do the normal derivative formula? Okay, the last type of problem that I wanna cover today, before we're done today, is do a second derivative. We have never done one of these. I want to attempt a single second derivative. Okay, so I'm going to scroll down. Okay, I'm going to do probably this one right here. I'm going to do number 1. Okay, this one says a second derivative, that says a second derivative. They're just written differently. Okay, the reason I put this on here, these are the notations that mean second derivative. First derivative, by the way, we talked about this earlier this week. First derivative is f prime of x. Right? That's the first derivative. It also could be written like this. I know we've written this before, or dy dx. I don't know if I've ever put that. Those are derivatives. If you want to find a second derivative, they put primes, 2 primes now, or they can write it like this: dy squared with a little 2 on it, and dx squared. Like that.
What is the second derivative?
Second derivative is acceleration now. So instead of just a rate of change, like speed, like velocity, now it's the actual change you're making in that speed. So if you're going really fast, 60 miles an hour, and you decelerate to a stopping point, there's a change that your car went, like how fast it stops. There's a breaking point. Like most cars, their brakes fade over time. So like you cram on the brakes, right? It stops really hard for the first couple seconds, then it kind of slows down for a little bit. And it kind of eases into it.
So it's the change of acceleration?
It's that change of acceleration. And it's a change in your velocity of your car. And there's like this motion where you want to cram on the brakes really hard, then you kind of back off because it was a little bit too hard. You got a little bit whiplash from it. Okay, so, all right, so here's the idea. Let's do the first derivative on this problem. So it's also known as f prime of x. So we're going to do the first derivative. So that's doing the limit as h approaches 0 for this problem. We're going to subtract the original problem off all over h. Okay, so we're doing the first derivative test. First derivative, this will be negative x squared minus 2x h's minus h squared plus x squares all over h. You would cancel out the x squares. We would have this left over, and we'd have to divide everything by h, and then plug in 0 for all your h's. So if I divide everything by h, I'm left with negative 2x minus h. If I divide everything by h's, and now what do I have to do is I have to plug the h as being 0. So it looks like my slope is going to be this. Or that's my derivative, I should say. That's my first derivative. Okay, makes sense how I plugged in 0.
Sure.
Okay, doing a second derivative is you pick up from here and you do it again. That's a second derivative.
Why in the world would you do that?
To find acceleration, the change in the speed of an object.
This
So-
is actually a lot easier than other times, to be honest.
Okay, so doing this second derivative, this is what we'd have. So we're going to find the second derivative, which is the limit as h approaches 0 again. But the new problem that we're doing is that negative 2x. So yeah, it's the negative 2x. So we're just doing that.
I'll do it on the back.
Negative 2x all over h. So we're just plugging the negative 2x as my function. So we're doing the negative 2x plus h, the negative 2x in the back, because we're using this function. Okay, this piece of paper, bring it back Monday. We're going to try to go back through it, and hopefully, just having time away from this, when you come back, we'll maybe start to see A, B, and C, or the 1, 2, and 3 on the very top a different way. Because sometimes, like, if we don't get it right away, it's good to just
Can you
take a
put that
break.
one back on the board again, so I can explain to you if I have it right? Does that make sense?
You need a break.
No, I need to understand if I understand it right.
Don't type your top paper because you can get frustrated.
You know, I'm not gonna, so that's not a problem.
I already did that and I printed it out.
Going back to 1.
Okay, no, the 3. Okay, go down to the 1, the C. Or whatever, no, go down. Okay, is the reason, no, this one. Right there, yeah, that's what I see. is the reason that it's not is because in the other one there was actually a slope, but this just stays on the line. Is that what you're trying to explain? Okay, so on the first one, the actual one,
Yes.
you said it had increasing slope.
Yeah, slope is
The reason
positive.
that this doesn't is because it's not even, it doesn't even have a slope.
No, what I'm saying is that these numbers you're looking at on this graph are literally the numbers for slope you were making now. So like when I said slope is positive, and
Yes.
you made up a number like 1, are these numbers, these literal dots, are they the number 1? No, because they're negative numbers, right? This is literally a negative number on the graph. What I'm trying to say is that when you come up with your slopes, like those numbers, like, oh, the slope is 5, the slope is 3/2.
Oh, I wasn't even looking at it like
Yeah.
that. I was just looking at
Yeah.
it, it just stays the same. It looks like it's staying the
No,
same.
it's literally the numbers plotted on a graph. So if it's below the graph, they're saying that their slopes are negative numbers. We don't have negative numbers. My slopes on the original problem were all positives. So you have to look for a graph that's all
because
above
it
the
went over
x-axis.
the
Yeah.
X? Okay.
Or Teddy's wrestling.
I really don't.
What?
Can I go back there?
Yes.
Teddy's wrestling.
Yes. We have homework due today. Make sure you get it turned in.
I don't listen to anyone.
Now, hey, if you see, hey, if that makes sense to you.
It did. I'll try to
Okay.
stay next period.
Okay.
See,
She was beyond frustrated, so
but
it's
she's
like,
gonna cry.
yeah, so that's one of those things like we just take a break.
Because you got mad at us.
No, I didn't.
Yes, you did. You're
No.
literally like, it's just a constant argument. I'm not gonna try to teach you guys anymore.